Hello guys, it's Derek Fuma here of derektofuma.com, and I just wanted to talk to you today about physics equations and what they really mean and what you can do during an exercise or an examination or a test, or even if you're just discussing, revising with some friends, what sort of things are important so that you can understand what you're doing when you talk about equations. So I'm here in my physics. Let me see if I like the size of this one. Maybe it's a little bit too small. I'm thinking of people that will be watching this maybe on a small device. So this is like one of the courses that I'm coming up with to put on a website called teachable.com, and it's not yet finished, but this is the experimental stage where instead of using PowerPoint, I'm using Evernote, because Evernote has a presentation mode, which is this button here. That's the presentation mode. So I can just click on that and I can change the size of the font to maximum, and I can change the color of the pointer to green, to blue, or to pink. Okay, so I much prefer the bigger font because it helps if you're watching this on a small device. And this is where I sort out all of my slides, so to speak. So if I click on that, that becomes one slide, but it becomes too big because it's too many words there. Okay, so I'd rather separate it like so. And then I would make sure that I'm on maximum there, and then I'd go to the start. So this is the start of my presentation. And it's physics course 1, physics equations. Okay, and you will not see any equations in this presentation. Maybe at the end I'll do one little example just to demonstrate how to make the subject a formula if you're given a formula, or if you know a certain formula, because sometimes you're given a booklet, and in the booklet there are equations, but they may not be in the form that you want to substitute directly into the question or with the data that you're given in the question. You might find it difficult to make the subject a formula. So I'm just going to show that how you make a subject of formula. Okay, so we're talking about physics equations today. So the main point, or one of the main points, and comes up as a question, is how do I remember an equation? If I'm in an exam, how do I remember which equation to use? And how do I even remember the equation itself? So sometimes you're given the questions in the questions, or in the test paper, in the exam paper, you are actually given the equation. But sometimes you're given the equation in a form which is not directly relevant, or it's not something that you can substitute straight away and get the answer, because you might need to do something to that equation before you can use it or you can substitute it. So it's important to understand what the equation actually means, and how we come up with an equation, or why the equation is the way it is. Once you understand that, then it becomes a little bit easier for you to be able to even remember some of the equations. You will not remember all of them, and some of them are going to be given, obviously, in the question. There's probably a formula booklet which comes along with the exam. Okay, carrying on. So we need to understand what an equation represents. Once we understand what it represents, then we're more likely to remember it. We're more likely to understand how we can use the equation. So it's important that we need to understand. It's important to understand what the equation represents. So basically, it represents an actual physical situation or phenomenon. So it actually represents something which is physical, a physical phenomenon. So a moving object like a car, if a car is moving, there's an equation that we can associate with the phenomena of movement. And so the equation is actually representing a moving car. Okay. So in this case, that's a really good example because it's showing you how an equation like F equals mass times acceleration or force equals mass times acceleration actually represents the force which is applied to a car of a certain mass and the acceleration that it is receiving because it is changing its velocity from one velocity to another velocity in a given time. Okay, so already you've got two velocities that you can measure. You have time, which you can measure. You can measure the mass of the car, and you can measure the force of the car. Okay, so it represents an actual physical situation or phenomenon. Phenomena is more than one phenomenon. Okay, so phenomena are the things that we observe taking place around us. So the things that we observe, the things that make us ask questions, those are the phenomena. For example, if I throw a stone upwards, it's going to fall down. Okay, so that's a phenomenon. And it's happening all the time. Every time we throw an object upwards, it comes down. Every time we apply brakes to a car, it stops. Okay? Every time we walk on ice, we slip and fall. So those are the phenomena, those are the things that are happening when it rains or after it rains or even when it's still raining. You observe a rainbow. Okay, so that's a phenomenon. And we observe that around us. That is what helps us to ask questions. So phenomena help us to ask questions. I've already said that. The questions help us to form a hypothesis and a prediction. Okay, so once we've asked a question like, why is the stone falling downwards and not going up and not coming back? Why does it always come back and fall on the ground? Okay, so that's a question we might ask. Then we might have a hypothesis to say something is pulling it towards the center of the earth or towards the ground. We can say that. We can make a prediction to say the heavier the stone, the quicker that it's going to fall to reach the ground. Okay, that's a prediction we can make. Are we right? We don't know until we carry out an experiment and find out. Okay, so that's the whole point of a prediction. It's what we think might happen based on the science that we already have in our heads. Okay, but because it's a new phenomenon or we're observing something different, we are asking questions and we're trying to answer them, but we need to investigate and carry out an experiment in order to be able to, or in order to be certain that our prediction is right or wrong, or our hypothesis is right or wrong. So the question helps us to decide how we are going to investigate the phenomena, if it's more than one, or the phenomenon, if it's just one occurrence or one observation that we're making. And by the way, it's just the observations that we make with our eyes, with our sense of taste, sense of hearing, sense of touch. Okay, those are the sort of those are the sense of hearing. Those are the senses that we use in order to investigate or in order to observe phenomena. Although, because our eyes are not so good, we use telescopes as well as microscopes for very small things and telescopes for very large faraway objects or very faraway objects. And those help our senses to observe phenomena which are either too small to see or too far away, like the other planets and the stars and the other galaxies. Okay, so using the hypothesis, we decide on the variables that we will choose to measure and to keep the same. So there's three things we can do. We can choose a variable that we will measure, and we can measure some of them, and we can keep some of them the same. Okay, it's important that we decide on variables because variables are the things that are measurable about the phenomenon. Because in science, it's not enough to just observe a phenomenon and explain it. We have to be able to measure it, and once we've measured it, we can have some data and we can show proof that this is why this is happening. So a variable is just a property which changes. So to vary is to change. So variables are things that are changing about a phenomenon. Okay, so a moving car has things that are changing. Okay, they are variables. Time is moving, distance is changing because it's moving from one point to another. The speed is changing, so all of these things are variables. The speed, the time, the acceleration, the distance, those things that are changing, those things are variables. And those are the things we can measure about the phenomenon. Otherwise, we can't really talk about the phenomenon without giving a quantity or a measurable outcome. Okay, so the variables we choose are called independent variables. Okay, so we choose a variable to say this is the variable that we are going to, for example, we can say for a moving car, we are going to choose distance moved. So we could say we're going to measure the speed, okay, at every 500 meters. So for every 500 meters, we measure the speed. For every 5 minutes, we measure the distance. Okay, so if we say every 5 minutes, we're going to measure the distance that the car has traveled, then it means that the independent variable in this case is the time because we are choosing when to measure. We're choosing when to measure, so we're measuring every 5 minutes. So that becomes the independent variable. The variable that we measure is called the dependent variable because it depends on the variable that we have chosen. So we might choose time, okay, as our independent variable. We choose time as our independent variable. Then we can choose maybe the distance, okay, because for every 5 minutes we're measuring the distance moved. So the distance depends on the time. It's depending on the time. And maybe we're measuring every half an hour or every 1 hour. We're measuring the distance that has been moved. So the distance becomes the dependent variable because it depends on the time that we've chosen. Or we can say we're going to measure the time taken every 20 miles. In this case, we've just swapped the two so that the distance becomes the independent variable and the time becomes the dependent variable because the time is depending on the distance that has been moved. Okay. Then the variable that we keep the same is called the control variable because if we decide to change everything about a phenomenon, if we decide to measure everything, then it becomes very difficult and very complicated. Okay, we could probably do it, but it becomes really, really complicated. And the equation of a lot of things changing is not a very simple equation. So we choose to keep some of the variables the same. For example, we can keep, in the example of the car, we can keep something which is changing about the car. We can keep the same. For example, we can decide to keep the same, a similar surface of road, for example. So instead of having the car moving in different types of surfaces, we can decide on one type of surface, or we can decide to measure the same car, or we can decide to measure. There's so many other things about this car that we can keep the same, so that um, the measurements become more reliable. Okay, so we separate variables into these categories because we cannot measure everything about a phenomenon. If we try to, we can measure, we can decide, we can carry out 3 or 4 or 5 different experiments in which we are changing the variables that we're measuring. We're swapping the independent and dependent and the control variables around, okay, just to be able to come up with a consistent result. So we use variables, formulate an equation. So this is where the equation is coming from. Remember, we said in order for you to be able to remember some of these equations, at least you need to understand where the equations are coming from. So equations are coming from natural phenomena which are happening, which we are observing. So in a question, you are given a scenario. Most of the time, you are told that a car is moving at a certain speed, blah, blah, blah. So that means that there are things that are changing, and I'll give you the variables in the question. So it's up to you to then pick up the variables, write them down, write down the dependent, independent, and control variables, write them down if they are given in the question, and then figure out which one you've been asked to calculate. Okay? So we could form a hypothesis about a falling object. We could say the higher the object is from the ground, the longer that is going to take to fall. Okay, so that's a hypothesis. Okay, so the variables in this case would be the distance from the ground and the time taken to fall to the ground. So those are 2 variables. But we'll also talk about the size of the object and stuff like that, and maybe air resistance and stuff like that. We could carry out the experiment in an environment where it's not affected by air resistance, for example. So what am I gonna do in this situation? I will change the distance from the ground. Okay, so this is the variable that I have chosen. So this becomes my independent variable because I've chosen to change the distance from the ground. So I could say drop the object from 50 centimeters, then from 1 meter or 100 centimeters, then 150, then 200, then 250, then 300 centimeters. Okay, so that's 3 meters. Okay, so I'll measure the time it takes to fall to the ground. This is the dependent variable. It depends on the height from that I have chosen. So I've chosen different heights, and the time to fall is going to depend on those heights. I will keep the object the same. Okay, so that becomes my that becomes the variable that I keep the same. Okay, so I'll keep the object the same and also the instruments I'm using to make these measurements. I'll try to keep the conditions the same by not changing the place where I'm carrying out the experiment. So if I'm carrying out the experiment in a physics lab, I will not move the experiment outside before I finish all of the measurement. Okay, if I would like to take the experiment outside, then that becomes a new experiment under a new variable, under a new situation. So which equation do I use? So the question is still, which equation do I use? So the equation we use when we're asked So which equation do we use when we're asked a question? Okay, so when we read a question, you will need to write down all the key information from the question. You will find that there are variables whose values have been given, and there are variables whose values you probably have to calculate. Okay, sometimes it's a two-step where you in part one of the question you're going to calculate a value that you're going to use in the second part of the equation of the question. So you write down the numerical values given and also the variable you're being asked to calculate. And what do the symbols in the equations mean? So the equations really, or the symbols really, they represent those variables. So the symbols in the equation represent the variables. These are the things we can measure about the phenomenon. Okay, so if we observe a phenomenon, we have to be able to measure it. And to be able to measure it, we have to come up with variables, and those variables are the symbols in the equation. Okay, so what does an equation really mean? Right, the equation describes the relationship between the variables, how the changing of one variable affects another variable or affects the rest of the variables. How do I make this subject of a formula? Okay, so this is one of the problems which seems to be a mathematical problem, but this is one of the problems that students have when they are confronted with this question. So I'm going to do a little demonstration, and I'm going to use the famous, let me use E equals mc squared. So E equals mc squared. Okay, so this is Albert Einstein's famous equation, which tells you how the energy of an object is equal to the mass of the object times the square of the speed of light in a vacuum. Okay, so if I'm given this equation, is Einstein's famous equation, and I want to calculate the mass. Okay, so for example, energy is a variable, mass is a variable, and the speed of light is a constant. Okay, it's a constant in this case. The mass can also be constant. Okay, and the energy will depend on the mass times the square of the speed of light. Okay, so we're looking at that equation, and let's say that these are the variables in the equation, but we want m. Okay, so the easiest thing to do is to come up with a triangle, to use the triangle method. Okay, so mc squared is the same as m times c squared, which means that m comes here and c squared goes there because they are multiplying. Let me use a different color for this bit. Put the red back here. So this red, yeah. And let's get maybe a blue here. So that's times. This is going to be dividing. It's dividing. So the E is going to come up in here. So this becomes E. Okay. So E equals mc squared. If we want m, then m, which is this m, is going to be E divided by c squared. Okay, so this is one way of doing this, but we can also just divide both sides. If we want m to be the subject, we divide both sides by c squared. So let me go up here and do this again. So if I have E equals mc squared, to make m the subject, I'm just going to divide both sides by c squared. And if I do that, the c squared is going to cancel out, and I'm left with m equals e divided by c squared. So that becomes, is that basic, but there are people who struggle with this. So I would recommend that you do the first one if you're not confident yet. Then if your math is that good, then you can use that one. Okay, so thank you for listening, guys. I've come to the end of this presentation. Hopefully you can subscribe and get to watch other videos that I'm going to make, or those that are already on this channel. Thank you for watching. Once more, it's Director Fuma here, directorfuma.com.